All right, so in this lesson, we're going to review our knowledge of basic mathematics in programming. Remember, there are a couple of different operators that we'll see, and there is a difference between integer and double mathematics at times. So we're just going to refresh our memories there, practice our math, because you will need to have a solid understanding of how mathematics works if you plan on incorporating any mathematical operations or changes into your program. All right, so you all do know that there are a couple of operators that do behave exactly as you expect. So addition, subtraction, and multiplication, both concerning just integers, just doubles, or a combination of the two, works as you would expect it to. You're going to get the exact answer that you think. Addition is just going to add the two together, doubles and integers, it'll work as you expect. Subtraction and multiplication, same thing, and that's because if you add, subtract, or multiply two integers together, you get another integer. If you add, subtract, or multiply two doubles together, you're going to get another double. So these mathematical operations behave exactly as you would expect them to. However, there is some math that behaves in ways that maybe you don't expect. So the big thing here is when it comes to division. And the problem is when you divide things like two integers. So really, when you divide two doubles, you're going to get exactly what you expect. However, what happens when we divide two integers together that don't divide evenly? And that's the case right here. So integer division does not behave as we would expect, because if you're performing math on two integers, it's going to produce an integer number. And the problem is that not all division problems containing integers result in an integer. And that would be the case right here, because we know that really, if we were to plug 14 divided by 4 into our calculator, it would spit out the number 3.5. But that's not the case in what's happening right here. It's only giving us 3. And so actually integer division produces math that we don't necessarily expect until we study computer programming and we study this new operator called the modulus. So what you see here is that integer division still produces an integer. So when you perform division on two integers, so for example, 15 divided by 4, they are two integer variables or two integer values in your program. What value it's going to give you is it's going to tell you how many times 4 goes into 14 evenly. So what this 3 represents is that 4 goes into 14 3 times in full. So when you perform division on integer values, it will tell you how many times that number goes into that second number. So how many times 4 goes into 14 in full. Then we have this second operator called the modulus that represents the remainder. So right here, this 14 and the percent sign is called a modulus. 14 modulus 4 pairs with integer division. So we know that 4 goes into 14 3 times in full, which then represents the number 12. We know 14 or 4 goes into 14 3 times in full. That gets us to the number 12. And this 2, this modulus answer, essentially represents the number remaining after you've performed that integer division. So after 4 has gone into 14 as many times as it can, the modulus represents how many numbers would be remaining. So essentially 4 times 3 gives us 12, but we're trying to get to 14, so we would need to add on 2 more. There would be a remainder of 2 after that integer division. So that is where division doesn't really work as we expect, and then the modulus comes into play to tell us how many would be remaining. So as I stated, we talked about how integer math has to produce an integer answer, double math or decimals have to produce some sort of decimal answer. So the modulus is something that is needed when performing integer math, essentially to give you the remainder after you've divided how many times that number can go into another number equally. So just one more example before I give you your own practice to do concerning the modulus and integer division. Remember that integer division produces an integer. It has to have an integer number. So if we have two integers, 16 divided by 5, we're stating how many times 5 can go into 16 equally. And I know that I can get all the way to 15 if I do 5 times 3. So I can get to 15 by dividing 5 in there equally 3 times. And then from there, the modulus represents my remainder. So essentially 16 divided by 5 is 3, with the remainder of 1 to get me back to 16. Now in double, remember in double math, this would in fact produce a decimal number. So this would actually produce the number 3.2. So note the differences between integer and double math. So what I would like you to do here is I'd like you to take a minute or two and do some integer versus double math on your own. So in your notebook, I expect you to work out these 10 problems, and then from there, double check your answers on the next slide. So make an important note. Do I have a double? Do I have just integers? Do I have a modulus operator? What does that modulus operator mean? And then from there, move on to the next slide and check your answers. So again, check your answers here. Double check how those problems went for you. If you have any questions, this would be an excellent time to ask and to get any of your questions clarified. So if you're struggling with the modulus operator, or you're struggling with integer division, or how the two tie together, please ask now. That's what I'm here for. I'm here to answer all of your questions. So just like when you learned Algebra 1 and you learned about the order of operations and PEMDAS, order of operations does come into play in computer programming as well, because we have to have a consistent way for your computer to read and solve mathematics problems. You've all solved problems before where a student didn't use order of operations and a student did, and you got two different answers. So just to refresh your memory here on how the order of operations works, remember the P represents your parentheses. Anything inside of parentheses comes first, and you start at the innermost parentheses and you work your way out. Then from here, anything with an exponent comes second. Then, and I like to put these on the same line so we remember that they have kind of the same order of precedence there. We do multiplication and division, and we go from left to right. So we don't do all multiplication and then do all division. We do multiplication and division in the next step, and we work our way from the left to the right. Then from here, we would deal with the modulus operator. So we deal with the modulus. And then finally, we do the same thing we do with multiplication and division, but with addition and subtraction. And we do addition and subtraction from left to right as well. So following these order of operations is key, and it's key when you're writing your own mathematical statement to understand what you're communicating to a computer. If you aren't thinking in the order of operations and you have a complex math statement that you're trying to ask your computer to interpret, you need to double check your order of operations and make sure that it's working in a way that you would expect. All right, so I have 5 math problems on the screen for you to try. This PowerPoint does not actually contain the answers to these, since there are some key concepts I want to make sure I hit on with you guys. So what I'd like you to do is practice these 5 in your notebook. If you'd like to work with a partner, you may. But you need to practice these 5 on your own. And when you are done, you need to come check in with me, and I'll kind of check you in and give you completion points based on what you have done. So this is a really good check for me and you to make sure we're on the same page with our math. Being a math teacher as well, I want to make sure our math skills are up to snuff before we move on. So practice these on your own, and then come and check in with me before moving on in the PowerPoint. I will be checking purposefully to see where our math skills are at to make sure that we can cover any of those concepts before moving on in monogame. You can note at the top it says if you have 2 integers, you can assume that integer mathematics is taking place. So if you are dividing, adding, subtracting, or multiplying 2 integers, you can assume that integer mathematics, so producing an integer, is taking place. So again, try these on your own, then come double check with me. Alright, so the last thing I want to touch on in this video are some of the shortcuts that you'll be seeing in monogame that students like to use all the time. So first of all, we've already talked about the num++ or variable ++. Remember, this is really just stating, okay, take whatever the number is, add 1 to it, and save it back inside that original variable. So That plus plus is just telling you to add 1. Minus minus is the same thing, but with subtraction. So it's saying take whatever number I have, subtract 1, and then save it back inside of my variable. Now these next operators do work just the same way that the plus plus was. It's just we're using a different number. We're adding 3 each time. We're multiplying by 2 each time. So this is really stating, okay, take my number, and I'm going to add 3 to my number, and then resave it inside of my variable. Same thing here. Take my number. I can see the operation right here. Going to take my current number. I'm going to multiply it by 2. That fifth line, taking my number, and I'm going to divide it by 5. And then here again, taking my current number, and I'm going to subtract it by 6. So those are just your key shortcuts that if you want to encode, make it a little bit shorter rather than writing out these longer statements that you see over here on the right, you can use these shortcuts to help you out.